Arr! This better be pulling our ship down. Sachin, my lad, pull the mast down.
Captain, we have bigger things to worry about. There'll be a dragon in our direction. So menacing.
Steven, fire the cannons.
Aye, fire in the hole. Captain, the rough rain has ruined all our matches. I can't light the fuse.
Alright, now what are you gonna do, mateys?
I guess we'll have no choice but to dodge it.
Blimey, we better get working quickly.
Sachin, get the brown paper.
What are we gonna do?
So we're gonna predict how our ship is gonna move relative to the dragon by modeling the wave using harmonic motion.
What the heck does that mean? How's it gonna help?
So waves resemble the graph of sine and cosine.
How do you start?
So first, we need to determine whether to use the graph of sine or the graph of cosine.
Oh, I remember this from pirate school. If we're at the crest or the trough of the wave, when we start, we have to use cosine because cosine starts at the maximum or the minimum. But if we're at sea level, we should use sine because sine starts at 0.
So give me Sachin. Where are we then?
We're at the crest of the wave.
It's cosine. I'll be next, my lad.
Alright, don't call me lad. Look at me. I'm the captain now.
Show me when I fall into Davy Jones' locker.
So you will follow as I command?
Bill sucking buccaneer. Hang him from the yard.
You carouser. Follow me if you want to live.
Son of a biscuit.
I withdraw.
Alright then. Now we need a period of the function.
How are we gonna do that?
You see, just as you said that we were at the crest of the wave, I started my pirate stopwatch. Now we can measure the time between waves. Since the argument of cosine is in radians, we must adjust the coefficient of t. You see, this is what the period is equal to, where b is the coefficient of t. We are converting radians to seconds. Captain June, what is the period of the function?
70.
So,
and since cosine is even, the sine of b doesn't matter. So b is equal to pi over 35.
Oh, I see.
Now we have the trigonometric function we are going to use. And the period. How will we use this to our advantage?
one more final thing. We need the amplitude for our function. Sachin, go find the distance from sea level.
The crest is 60 feet above sea level.
Alright, now we need to multiply this function by 60 so that the minimum and maximum of this function is 60. Now, we finally have a function that relates our height in relation to time.
Is that all we need?
There's also the phase shift, which shifts the graph by some amount. Let's call it n, by replacing t or our independent variable with t minus n. But we don't need it since I'm using my stopwatch. No.
But don't we need the time between us and the monster? Ah yes, I figured it out. The ship is going 60 miles per hour. Judging by my 16th century measuring tool, the monster is 2 miles away. That means we are going to hit the monster in about 120 seconds.
Oh, using the time from the stopwatch, we can determine our height when we reach the monster.
Oh, according to the simple harmonic model, we will pass over this monster.
Yay!